I'm discussing about adiabatic expansion of ideal gas. First of all, thermodynamics. Thermodynamics is the branch of science which deals with the study of the different forms of energy and their interconversion. Adiabatic expansion of ideal gas, when the expansion of ideal gas is carried out at constant heat, so that no other heat can enter or leave the system, then it is called adiabatic expansion of an ideal gas. Reduction of TB relation from the first law of thermodynamics, dq equal d plus pdv. Dq equal to 0 for adiabatic process, that is the heat is the constant. We know that Cv equal to d by d over dt. That's why d equal to Cv dt. And also, we know that for 1 mole of the ideal gas, Pb equal to RT, B equal to RT by P equal to RT by V. Substituting the value of Cv, d, and P in the equation first, we get 0, d equal to 0, Cv dt, RT by B dV. Simple arrangement, RT by B dV equal to minus Cv dt. Again, arrangement dV by B equal to minus Cv RT dt. When a temperature has changed from T1 T2, then volume of the ideal gas is changed from V1 to V2. For approximate calculation of Cv is may assumed to be the independent of the temperature. Integrating the equation 5, we get V1 V2 dV by B minus Cv by R ln T1 T2 dt by T, and ln B2 B1 B2 B1 and minus Cv R ln T2 T1 T1 and ln B2 B1 equal to Cv R ln T1 T2. This negative sign change, and now question 7 can be written as ln B2 by B1. B2 by B1, CB by CP minus R, simple arrangement. This ln T1 by T2, CP R equal to CP minus CB. Again, a simple arrangement. This is the again in left hand side, and this CP by CB CP and ln B2 by B1 ln T1 by T2. That's why CP over CB minus 1 ln B2 by B1 equal to ln T1 by T2. And CP by CP is the gamma minus 1 ln B2 by B1 equal to ln T1 T2, where gamma is the molar heat ratio, and gamma is 1.66 for monoatomic gas, and gamma is 1.44 for diatomic gas, gamma 1.30 for triatomic gas. Above equation 8 can be expressed as ln B2 by B1 gamma minus 1 ln T1 by T2. Taking antilog on both sides, B2 by B1 over gamma minus 1 T1 by T2. T1 B1 gamma minus 1 T2 B2 gamma minus 1 TB gamma minus 1 constant. Again, from the equation 7, ln B2 by B1, ln T1 by T2, CB by R, we also know that ln Y, ln YX, taking the antilog on both sides, B2 by B1 equal to T1 by T2, CB by R. Again, rearrangement B1, T1, CB by R, B2, T2, CB by R. Taking the R by CB power of the both sides, B1, T1, CB by R, CR by CB, and B2, T2, CB, 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 RR, CB, CB, RR is cancelled. That's why the T1, B1 is R by CB, and T2, B2, R by CB. T1, B1, and R is the CP minus CB. Okay, similar and CP minus CB, and a simple arrangement is CP minus CB minus 1. Minus 1, that's why TB gamma minus 1, CP by CB is the gamma. This is the another form of the temperature volume relationship in adiabatic change. Deduction of the PV relation in the above equation 11, equation 10. We know that T1 B1 gamma minus 1, T2 B2 gamma minus 1. In for ideal gas, in case of deduction of PV relation, we should have to substitute the temperature. That's why T equal to P by R, and T1 at P1 B1 by R, T2 at P2 B2 by R. That's why the substituting the value of T1 and T2 in equation 1, we get P1 B1 R, P1 gamma minus P2 B2 R, B2 gamma minus 1, and simplifying P1 B1 1 plus gamma minus 1, P2 B2 1 plus gamma minus 1, P1 B1 gamma, P2 B2 gamma. That's why PV gamma is constant. This is the pressure volume relation in the adiabatic change. A deduction of the TP relation, again, we know that P1 B1 gamma equal to P2 B2 gamma. We have to substitute in the TP relation the volume. That's why in from the ideal gas, from the 1 mole gas, PV equal to RT, B equal to RT by P. B1 will RT1 by P1, B2 equal to RT2 by P2. That's why equation P1 RT1 by P1 gamma. P2 RT2 B2 gamma, and P1 gamma, P2 gamma, P2 R gamma T2, R gamma gamma cancel, and that's why P1 1 minus gamma T gamma, P2 1 minus gamma T gamma, and T1 gamma P1 1 minus gamma T. That's why T gamma P 1 minus gamma constant. This is the simple derivation of the deduction of the adiabatic expansion of the ideal gas in the deduction of TB relation and TB relation and TP relation. That is the adiabatic gas three relation: TP relation, PB relation, and TV relation. Thanks for watching. Thank you for your patience. That's it now. Bye bye. See you again.